there's a population proportion which we use pi. Remember, pi is a population proportion. It's not 3.14156. Yeah, it's just a proportion. So we use sample proportion to estimate the population proportion. So this is the you have to use this one first to test whether they are normally distributed or not. If they are satisfied this one, then you can use the formula here as a standard error. This is a standard error. Yeah? So provided they satisfy the normal distribution formula. So you can use this formula here. Z is equals to just like x bar minus mu. X bar is sample mean, so this is sample proportion. Minus the mu, which is the population proportion, over the standard error, which is this one here in the case of a proportion. Yeah? So all you need to do is just substitute inside there. Let's look at one example. If true population proportion of voters who support proposition plan A is 40%, so population proportion is 40%. Population proportion is 40%, and they ask you what's the sample proportion? Probability of sample proportion between 0.4 to 0.45% in the sample of 200. So what you need to do is just substitute the whole formula, but you have to test first whether they satisfy this one here. Yeah. So n times p must be greater than p or pi. Yeah. Sometimes they use p, sometimes they use pi. Population proportion. So let's look at this one here. N is 200. What is pi? Pi is 0.4. 0.4. So n times pi. Does it satisfy? Does it satisfy more than 5? N times pi is 80. N times 1 minus pi is 120, which is not written over here. So I suggest that you write somewhere here n times pi. N times pi equals to 200 times 0.4 equals to 80. So let me write it down at the side there. So you write down n pi is 200 times 0.4 equals to 80. The other one is n times 1 minus pi is 200 times 0.6 is 120. Both are more than 5. More than 5. So this thing says that they are normal. They must be normal before you can continue. Yeah? So this is the condition. Condition, you have to satisfy this one first before you can continue. Yeah? So the one that you wrote there, more than 5, is this one here. Yeah, so they are satisfied, so they can use this formula here. So this is where you continue. First you write the one n times pi and n times 1 minus pi, means that they are normal. Then you can continue with this one here and convert it. Yeah, convert it to standard error. This is a standard error. And so what's the probability of sample proportion between 40 to 45%? You just substitute in, standardize this. And you can find out 0 to 1.44. So what's the probability? You can check it out yourself, DIY. Even though again the answer is given here. 0.44 is 0.4251. Yeah, but I would rather cover this one here and try out DIY and check the answer. Okay? So that's pretty much the end for this chapter. So it's good that you, as you study along bit by bit, every slide, every few slides, you pause and you try to summarize it. So this is where the summary is, yeah? To test for normal. You use, for this case is n greater equals to 30 CLT. How about this one here? So this is sample, sampling mean, sampling proportion, S. And what is this formula here? For the standard deviation, which we call it standard error of the mean, this is standard error of the proportion. The formula is this one here. P 1 minus P over N. So this is a standard error, yeah, which what we call it P here. So what's the formula here? The formula is the same thing. Z is equals to, instead of X bar, you have a PS, sample mean, sample proportion, minus population mean, population proportion, over standard error, which is from here. So the same thing here, P or pi, 1 minus pi over N. So this is also, some textbook use pi instead of P. They are actually the same. It's just notation different. And how do you know whether they are normal or not normal? What did we just do just now? N times pi must be greater than 5. N times 1 minus pi greater equals to 5. So from that, you can say they are normal. You can use these two formulas. Yeah? Central limit theorem. So let me enlarge that. Alright, so let's continue with the lesson. We'll fill up the rest later. Yeah? So let's talk about confidence interval. What is confidence interval? The idea is very simple. Yeah? If you understand the whole thing, the concept, overall, we go top down. Yeah, you understand the concept, then the calculation, you just need to understand, you follow the formula. That's about it. Always recall where we learned earlier. Lesson 1, we mentioned that statistics is applied mathematics. So we are not concerned about how to get this formula, how to get this formula, but we are concerned which formula to use in the exam. You'll be given formula sheet. So you must know which formula to use here. So let's look at the formula sheet. What kind of formula sheet you'll be given? You'll be given. Let's try this one here. So this is the formula sheet. Yeah? So you must be able to read and understand what are these formulas. This formula will be scattered everywhere. As what you see, as what you get it. But if you put it in that table, just now we show you, you kind of know when to use what formula. Yeah? So it's better than all the formulas scattered everywhere. Alright? But nonetheless, let's move on to the here. What is confidence interval? Okay. Alright. Confidence interval. Confidence intervals, let's look at the bigger picture here. Yeah? Population. Sample. We want to find out what is mean. How many kg is this one here? Sometimes we need to find out what is the population parameters to make some kind of decision. But we cannot find out what is mu. The only way to find out what is mu accurately is the only way is to conduct a census. But we are not going to do that. There are two types of parameters. One is the actual number, which we call it mean, population mean. The other one is the proportion. Yeah, we want to find out what proportion of the population has certain kind of feature. For example, I want to know, out of the whole Kaplan here, what proportion of people wearing glasses? What proportion? And our dear friend, the white angel, will love to do this. You know what's angel, right? White angel? The PAP. They will want to know before voting, how many percent will vote for them? How many percent will be sitting by the fence? How many percent will not vote for them? So these are fractions, these are proportion that is very important to make for the population. But we cannot do this unless you conduct a census. In the case of voting, when you conduct a census means the actual election day, right? So we cannot do that every time. So what we do is a sample. For this one here, we use X bar to estimate what is the mean. For this one, we use a sample proportion to estimate the population proportion. But can we get the exact number here? Let's say this is a 50.5 kg. Does it mean that this will be exactly 50.5 kg? Do you think so? Unlikely, right? We got so accurate, so one, unlikely. Yeah? So likely to be slightly off. But how much off? That is the concern of this topic here. First thing, point estimate. When you use X bar to find out what is mu, that is what we call it point estimate. What's the chances of this one is accurately predicted by this one here? Chances is high or low? Extremely high or extremely low? Extremely very, very, very low. Yeah? It's like saying, if I take the three of them, what is their average body weight? The three of them, X1 or W1 plus W2 plus W3. I've divided by 3, and that is an X bar, and let's say this is a 53.5 kg. What do you think the population? Is it exactly 53.5 kg? What is the chances that is it exactly the same as this one here? High or low? Not just low, extremely very, very low, isn't it? So I take an X bar just to predict this one here is extremely very, very low. So I ask about the chances to get this correctly is very low. I write down the chances here. So if I want to increase the chance, will I use one point to another point? No. What I would do is I will, let's say this is 50 kg. I do not know what is my mu. The aim of this topic is to find out what is the mu equals to. What is the mu? So what I do is I use X bar plus minus maybe 5 kg. So X bar is 50, meaning that it is between 45 to 55 kg. My mu will fall inside here. Is it higher chance than compared to point to point? Yes. What if I say this higher chance is not good enough? I'm risk aversive. I want to have more chances. More correct guess means that lower unlikely wrong guess. So if I want to increase this one here, what will I do with this one? Can I say it's X bar plus minus 10 kg? So I widen this one to from 40 to 60. 50 plus minus. If I said I want to be even more totally risk aversive, so what will I do? I will say plus minus 15 kg. Maybe from 35 to 65 kg. Remember, we are not talking about one student. We are talking about the mu, the population. Yeah, one student, high chance of outside of 65, high chance of less than 35. But as a mu, do you think high chance or low chance? Outside of this range? Very low chance. Because there are people who are super heavy, it will be negated by people who are normal and those who are lightweight. Yeah, so there are people who are extreme, outliers, but it will pull back to the normal range. There are people who are super light, it will bring up to the normal range because most of them will be around this interval. Yeah, so because we are not talking about one individual, nor two, nor three, I'm talking as the mu. Yeah, so typically when we talk about higher chance, we change this to confidence. So if I want to have higher confidence, I will increase the interval. So this confidence, we call it confidence level. Typically, we use 3 types of confidence level: 90%, 95%, and 99%. As I increase the confidence level, What is the risk? Higher or lower? Lower. This one means that if it is 100%, what is the risk? 0% risk. Is there such thing as 0% risk in business? No. Therefore, we don't deal with 100%. The very highest most we deal with is 99%. Even 99% usually means that super risk aversive already. But we cannot say 100%. In business, you cannot say 100%. Just a few months ago, some 6-7 months ago, last semester, I was at Orchard Road, sitting at the Starbucks, there's nothing to do, yeah? So I was looking around, I don't know why am I looking around. So I bumped into an old man, also just like me, sitting down there. He is about 60, late 60s, I think, around there, and I was just striking a conversation with him. He was a businessman, a small businessman in the 80s, in the 90s. He retired long time ago. And he related to me his story. As a small businessman, he has a contract to do some improvement for the Changi Airport. So the material, he was a small contractor and things like that, the material he signed is a supplier from Japan. And the Japan businessman was flying all over the world. I don't know where this Japanese came from originating, but his destination is to come to Singapore to sign a contract with this Singaporean businessman. Arrival already in Changi Airport, and he called this old man, said that I'm already at Changi Airport. Almost 100% sure he will come out and sign the contract. And guess what? First time in Changi history, Singapore history, terrorists came in. Hold everybody hostage, SIA. You probably know what is the history there. Yeah, those people who are in the army, you know the history. Singapore was held hostage. I think SIA, one of those, in the 90s or in the 80s, something like that. Yeah, over the night. Then the commando stormed in and killed all the 4 Pakistanis. Yeah, it's history, it's real. And chances is almost 0, and yet no such thing as 0 risk. Yeah, there's always the highest is 99%. No such thing as 100%. Even though remote chance, but it's still 99%. All right. So when we talk about confidence level, similarly, what is related to this concept is this interval. So this interval, you notice that confidence level. So we call this confidence interval. Confidence interval, which is this title here, confidence interval. Yeah. So as we move up, the higher confidence level, what happened to the confidence interval? Wider or narrower? Wider. So this one here, confidence level, there's another symbol for it. It's called 1 minus alpha. So remember this, 1 minus alpha represents confidence level. Typically, we are talking about 90%, 95%, and 99%. If the question stated very clearly, you have to follow the question. But if the question did not state, by default, we use 95% confidence level, which is your assignment. Your assignment did not state what percentage. So you always use 95% if it is not stated. Yeah? Same thing in your project. It's worldwide. We take it as 95%, unless your boss says that I want 99%. But usually, the boss also don't know much about statistics. So you can use 95%. Alright? So you look at this one here. It's very much is 50, the X bar here. Plus minus, plus minus, plus minus. Now let's look at the formula. The formula is actually 90%, 95%, 99%. Confidence interval is X bar plus minus Z sigma square root of n. This is very much like 50 plus minus 5, 50 plus minus 10, 50 plus minus 50. So we start with the 50, which is the X bar. Of course, this X bar 50 happen to be just this formula here. Yeah, this instant, this example. But of course, in the exam, if the sample says that X bar is 70, then you have to use 70 plus minus something. We start with the X bar from the sample. Yeah, of course, in this example, we use 50. Doesn't mean that it has to be 50. Depends on the question. Okay, so let's look at 90, 95, and 99%. What is this value? This is the Z value, yeah? Z value. And you learned before, value and area are not the same. So let's find out what is this one here? What is this number? The Z value in this number, 90%, 95%, and 99%. So when we say 19%, 1 minus alpha is 0.9, 90%. What we are talking about is something like this one here. This is the Z, this is a 0. When we talk about 90%, this center is 90%, 0.9. This is Z. You need to find out what is this, what is this. Give you 2-3 minutes, try out, find out what is this value here. Yeah? This is what we have learned with last lesson. Given area, find value. Try this one out, which is what we learned A and B. Can someone find out this is 1 point? Good, 1.645. So symmetrical minus 1.645. This is the case of 1 minus alpha is 0.9, which is what we call it confidence level. How about 95%? 90% here, 95% will be wider. So this whole thing here is 0.95. This is 0.90. What is this value here? Try it out. And lastly, %, will be very far ahead.
1.645 is 95%, right?
1.645 is 90%. Yeah, not 95%. See carefully. See carefully. Your calculation, remember, big left. Big left. Okay, let me just go through this one first. This one, I leave it to you to find out because I will explain to you this one here. How do you get 1.645? What's the Z value? Z value is plus minus 1.645. This one plus minus 1.96. This plus minus 2.575. How do we get this one here? It is something like this one. Is this symmetrical? Rule number 3, symmetrical. So this is A, this is B. What is B? Just B alone. 0.45. You look at your Z table. Your Z table, did I ask you to write A equals to P? Point there? Yes. And did I ask you to extend this one? Stop where? Stop here or stop all the way? All the way. That is big left. Is this big left? Is this big left? No. Big left is all the way. So you have to do all the way. In order to use this table, you have to use all the way. Don't stop here. Not here, but all the way. So which means that tell me what is this number here? If this is 90, this must be how many percent? 0.05. So what is the big left? 0. What is the whole area to the left? 0. Good. 0.95. Because this is 0.9. This is 0.05. 0.95. Look left, look top. This is 1.645. Yeah. Remember this table doesn't stop halfway. That's why I asked you to draw the arrow all the way to the left. Not stop halfway. and this is a big left. The same thing applies over here. Check it out from homework. As a homework, this whole area is 0.975. And then you can find out this is 1.96 minus 1.96. So, back to this one. So you can practice this one here at home. So, 90% is plus minus 1.645. 95% is plus minus 1.96, and this one plus minus 2.575 into this Z value. Yeah? And let's look at the example right now from the PowerPoint slides. Interval estimate. Point estimate. We don't use point estimate to predict, to estimate the mean. We don't. But we use the point estimate as the midpoint. X bar 50. We use 50 plus minus something. So the point estimate is just used as the midpoint to have plus minus. The plus minus the whole interval is what we call it confidence interval. Your job is to find out the lower limit as well as the upper limit. Once you find out lower and upper limit, your job is done. This chapter ends. Actually quite easy, as long as you find out what's the lower limit. It's something like 50 plus minus 5. So you find out for me, bottom is 45, the top is 55. You find out these two, done. But of course, you have to write the answer in a statement that is acceptable. But basically, you find out the lower limit and the upper limit. Yeah? So this is what you need to do. So for example, X bar. X bar is used to estimate population mu, correct? So write down mu over here. Yeah? Sample proportion is used to estimate population proportion. Sample proportion, population proportion. An example of this mean things is that what's the average body weight in Kaplan? You use a sample body weight, find out what is the population body weight. An example of proportion is what's the percentage of Kaplan students wearing spectacle? What's the percentage? Is it 30% or 40%? So we use a sample of 100 students, maybe in this class, 40 students. How many of the 40 wear glasses? If 10 out of 40, that means 25%, then I will say that over here is about 25%. Okay, so plus minus 5%, plus minus 5 each. This is an estimate, interval estimate, which is what we are trying to do, to find out the lower and upper limit. Yeah? Confidence interval, we use 90, 95, 99%, 100% meaningless. We never do the 100%. If you are lost, let's start beginning. Hopefully within 1 minute or 30 seconds you understand. I want to find out the population mean, which is mu. There is unknown, I want to find out. So what I do is I take a sample, random sample. How do I do that? Back to lesson 1. Stratified, cluster, systematic, simple. Remember that? So I took a sample. From that sample, I find out what is the X bar, sample mean. If the X bar is 50, then I use my 50, which is a point estimate, to create an interval, 50 plus minus. So that interval, lower limit, 40. Upper limit, 60. So we have a 40 to 60, lower and upper limit. That is what this topic is all about. To find out what is my mu, we use an estimate, interval estimate. Yeah? So, I just wrote down just now X bar, point estimate X bar, plus minus Z, which is what we call it critical value, and sigma over square root of n. So, let's add on to this one here. So this is the critical value. This one here we learned earlier last chapter. We call this, what do we call this? Standard error. So this is the standard error. Combined together, what do you call this one here? M MOE stands for Ministry of Education. No, MOE stands for margin of error. Yeah, please write down margin of error in your PowerPoint slides. So this is margin of error. Okay, margin of error is big means that wider. Margin of error is small means 50 plus minus 1 kg. Margin of error is big, 50 plus minus 10 kg. Yeah, so it depends on what is your MOE. It's written 1 minus alpha. Now let's look at when sigma is known. Sigma is known, we use Z table. So you can remove this alpha divided by 2. Please remove this because sometimes it causes student confusion. So this alpha divided by 2, just remove it. So have we seen this formula just now? Yes. Let's look at one example. Yeah, 95%. 95% is plus minus 1.96, which we did just now. So important things is there are 3 percentage that you need to know. Good that you remember it. What are the 3? These are the 3. 90, 95, 99. And the Z value, 1.645, 1.96, and 2.575. Change this to 2.575. Let's look at one example here. Take a few seconds and try to look this one. So, a sample of 11 circuits from a large normal population has a mean resistance of 2.2 ohms. We know from the past testing that the population standard deviation is 0.35. So, what is this one here, this statement, these 3 words? What's the notation? Population standard deviation. What is the notation? Sigma or S? Sigma or S? Population standard deviation. Population standard deviation. Sigma. When sigma is known, what do you use? Sigma is known. Sigma is known. You use Z. Yeah. So you use the Z table, and N is 11, X bar is 2.2, and 95% confidence interval. Can you recall 95% was the Z value? 1 point? Good. Try to remember because 10 times question asked, most of the time they ask for 95%. So it's good that you remember. If you've forgotten, you have to calculate one by one or check the Z table, which may not to be an error, yeah, in the exam. So it's good that you remember that. So you just substitute it. 2.2 plus minus 1.96, sigma given as 0.35, and you just write down over. So this is the lower limit, and this is the upper limit. So it's just like a human being over here. The lower limit for 95%, the lower limit is over here, 1.9932. The upper limit is arm stretched out. Maximum arm length, maximum is 2.4068 on the upper limit. So then, you can also write it in this manner here, in this manner. But which one is preferred, first one or second one? Okay, let's try this one here. In the exam, oftentimes, we see students do this one here. Like just now, the example is you have your PowerPoint in front of you. This is 10, that says 1.9932. And upper limit is 2.4068. Does it matter equal sign or not equal sign? It doesn't matter. Later I'll tell you why. You should know. Yeah. So let's put as equal sign over here. So all the other way is 1.9932 and 2.4068. If it's a 3 marks, this one will get 3 marks. This one will get 0 marks. Why? Anyone spot the mistake? Yes. Some of you don't spot the mistakes, means that you use this one, you get 0 marks. Why is that so? Look at this one here. What is the purpose of studying confidence interval? What is the aim? To find what? Mu. Are we here to find the x bar? No, x bar we have it. We want to find out the mu. So if you write this one here carelessly, that defeats the whole idea of finding the mu. The whole idea of studying confidence interval is to find out what is mu. So a lot of times students write this one here. In QA, probably 2 out of 3, minus 1 mark. Over here, we are very generous. We minus all the marks. Because we don't see this as careless mistake. We see it as you don't understand the concept. The concept of confidence interval. Why do we want to study confidence interval? Is to find the mu, not to find the x bar. And why do you give us the answer with the x bar? It should be 1.9932 mu 2.4068. So for that reason, we recommend you use this one here. This one, you don't have to write anything. You can get full marks. Provided there are students who write this one here, then of course minus mark, 2.4068. Somebody who like to be exposed, you must close the window lah, huh? Then you can get full marks. Otherwise, just 2 number comma, we do not know what is that. Yeah? So you just cover it and you can get 3 marks out of 3 marks. Please remember. And the other things is, let me just ask you, let's say it's 40 plus minus 5 kg. What would you write first? What would you write first? 35, and this one here? 45. Now, let me just try out here. Yeah? Make it very, very fast. Think very fast. 50 plus minus 5. 45 to 55. How about 62 plus minus 8? 62 plus minus 8. What comes to your mind first? 70. 62 plus minus 8. Most of us comfortable with 62 minus 8 or 62 plus 8 first? Plus 8. So oftentimes we have this kind of things here. 62 plus minus 8 kg. People write 70 here and start thinking 62 minus this one is 54. Does that make sense? How about try this one here? Tonight, let's go for movie. And I wait for you at the Orchard Road between 10 and 9 o'clock. Make sense? 10 and 9 o'clock? You wonder 10 o'clock until tomorrow morning 9 o'clock, isn't it? Yeah? In my wallet, I have between $20 and $10. Make sense? Always small number first. And yet, a lot of students write this way here. Because what pops to their mind is a plus first, not the minus first. Many students in the end. We will not minus a lot of marks, just 1 mark. And that 1 mark could be a crucial 1 mark. Alright? So let's come back to this one. So after you get this one here, that's not the end. You get pretty much the answer, job done, but you have to conclude it. We are 95% confident that the true mean, means the population mean, is between this and this. Remember, lower and upper limit. Yeah? So that is for the Z. Now what happens if sigma is unknown? Sigma is unknown, you use something called T distribution. Again, remove the alpha divided by 2. Remove this one here. And what is T distribution? Can you take the T table behind your study guide? Z table, area and probability is here, value is over here. Yes, did I ask you to write this one here for the Z table? For the T table, it's the other way around. The T value is over here. Value is not outside, but value is inside. The area is not inside, the area is outside. No, outside is on top. So this is the probability, also equals to the area. And it's split into three. One is cumulative, which we ignore. One is one tail, the other one is a two tail. And this one here, not a value, but what we call it degree of freedom. The definition is n minus 1, degree of freedom. Let's look at how we can use the T table. What's the T table for? We want to find out the T value. For what purpose? For this purpose here. Have the n in mind. We have the Z value. Now we want to find out the T value in this formula. The same thing, Ci, x bar plus minus. Instead of Z, we use a T. Instead of sigma, we use the S. So it's 90%, 95%, and 99% Ci equals to this formula. When do you use this? When do we use this? As what we mentioned in the PowerPoint, we use this when sigma is known or given. We use this is when sigma is unknown. We use S. After all, S is still a standard deviation, except that this is a sample standard deviation. This is the population standard deviation. Recall this sample and population right over here. Population. Here is a sample. Sample standard deviation is S, population standard deviation is sigma. We learned that earlier. Okay? So, you need to know what is this T value. You need to use the T table. And T table need two pieces of information. One is the area, one is the degree of freedom. And degree of freedom is defined as n minus 1. So let's have some practice here. Let's do this one here. Sample size. Let's say 1 minus alpha, 1 tail, 2 tail, T value. Let's try this is 20, this is 15, this is 10, and this is 0.95, this is 0.10, this is 0.05. What is the T value here? Let's look at this table. Let's write down here first. So if it is like this given, what does it mean to the degree of freedom? Can someone tell me what's the degree of freedom here? Minus 1. So what is degree of freedom here? 19. This one? 14. This one? 9. So look at the 19, 14, and 9. Look at the 19. So you took the 19 over here, and 1 minus alpha. What's 1 minus alpha? We learned that just now 1 minus alpha is confidence level. So where's the confidence level? Right below here. 1 minus alpha is basically the confidence level. Look for 0.95. Look up here, and that is the number that we are looking for. So can someone read out for me what is the T value here? 2.2262. Everyone okay with that?
2.09.
Is it 2.262? You look at the 19, degree of freedom is 19. 2.093. Okay. Everyone okay with that? How about this one here? Now is n is 15. So degree of freedom is 14. but is given one tail is 0.1, one tail. So look at one tail here, 0.10. Go down, and degree of freedom is 14. What is this number? 1 point. So this is 1.345. How about the person beside you if they are lost? Now fill up for me what is this one here. Two tails. What is this number here? 2.262. Is it 2.262? Yeah? So this number here fit in this whole picture. T table need us to know what is the degree of freedom, need us first to know what is the area. Because degree of freedom is this part here, left hand side. And the area is top part or the bottom part. That's where we can crisscross, find out what's the value. And this is the value where we have to substitute into here. This is the T value, just like we did with the Z table. But right now it's called T table. Yeah? So let's move on. So we have 12 here. Now let's look at the, why don't we constantly update this one here? So if we have the sigma, what do we use? Z or T? If you have the sigma, you use Z. If we don't have the sigma, you use the S. What do you use? T. And you see that this table getting more populated and getting more cracked. You will fill up more. Yeah? So, let's continue with the PowerPoint slides. So this is the confidence interval. Yeah? So I won't go through this anymore. How to read the T table. This is not aligned, you can ignore this one. This is the VBS 46 T table. Very complicated. And of course, over the semester we improve. Yeah? Trying to help the students. Imagine you use this one here. It's not that easy. You can, but it's not that easy. Now your T table is so much more friendlier, so much more complete. Yeah? So let's look at this example. Try out on your own, try to understand while I create one problem here for you to practice. Yeah? Okay, I hope you can understand that simple working. And with that, I give you one hands-on here. Okay, take a photo, try it out, and you need a break. Okay, 15 minutes break. We'll come back. Hopefully, 1 5, 1 5, not 15. Yeah, 1 5 minutes break and.